Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2022, Paper 2, Variant 2. In the last two videos, we have discussed from question number 1 to question 20, and in today's lesson, we will start from question number 21, and we will try to finish all the remaining questions. And we will discuss these questions in detail as always we do, so you can improve your conceptual understanding and also you can have better understanding of these questions. Let's study together. Let's improve together. Before we start working on remaining questions, let's discuss a little bit about syllabus update because it's very important. You need to understand which topics you don't need to study for upcoming exam. According to new syllabus, digital electronics is not part of new syllabus. Gas laws have been removed. Measurement of temperature means thermometer is not part of new syllabus. Pressure is also not part of new syllabus, so you no need to study about barometers, no need to study about manometers. And thermal capacity also has been removed, so it is not part of new syllabus. So when we will solve these questions, we will just skip questions about these topics because these topics have been removed. Question 21 says the angle between an incident ray and the surface of a plane mirror reflecting the ray is 70 degrees. What is angle of incidence? Quite straightforward question if your concept is clear. Let me explain you this one with the help of simple diagram. So simply we can sketch. This is representing a plane mirror. We can also draw these lines here. So this is representing plane mirror. So this is plane mirror. For this question, it is given to us that incident ray. So this one is the incident ray. So it strikes this mirror and there will be another ray. That one is reflected ray. So this one is reflected ray. We can also add arrows here. So this one is incident and this one is reflected ray. For this question, it is given to us that the angle between the surface of the plane mirror and incident ray is 70 degrees. What is angle of incidence? Angle of incidence is the angle between incident ray and normal to the surface. So this is normal. So we have to take this angle. So this is angle of incidence. So in this case, angle of incidence is equal to 90 minus 70. So this is equal to 20 degrees. So the answer for this question is A. So you need to understand angle of incidence is the angle between normal and incident ray. So we can say I, this is angle between normal. Angle between normal and incident ray. So this is the concept you need. So this is the angle between normal and incident ray. So this is the angle of incidence. And this one will be angle of reflection. Question number 22 says the diagram shows the air molecules in part of a sound wave at a particular moment in time. Which statement is not correct? So this question is about sound waves. I mean how sound waves travel. First thing we need to understand, sound waves, they consist of compression and rarefaction. So when sound travels, compression and rarefaction, they also travel. It simply means that if you focus at one single point, let's say if we focus at point X, we will see, in this case you can see first of all we have rarefaction. So this is representing rarefaction. So we can also label this one. So this is representing rarefaction and this is representing compression. So if you look at point X, now we see at point X there is rarefaction, and in next moment we will see there is compression, because when sound wave travel, compression and rarefaction also travel. So that's the point you need to understand, and they travel in direction of wave. So if you have understanding of these points, you can answer this question. Let me explain you this one with the help of animation. You can look at this animation and you can see compression is moving, or you can say rarefaction is moving. As the sound travel, compression and rarefaction, they also travel. So it simply means that if you look at certain point, you will see with time, you will see compression, then you will see rarefaction, and so on. I hope you have understanding of this one. Now let's move on to these given options. It is given to us there was a compression at X. Yes. If we have rarefaction at X now, before, if you go back in the past, there will be compression. Then it is given to you later. So this option is correct. Later, there will be a rarefaction at X. Yes. This part of the wave is traveling horizontally across the page. Yes. Sound waves, they travel in one direction. So A, B, and C, these options are correct. But we need to find out which one is not correct. The part of the wave is traveling towards top of the page. It's telling you part of the wave is moving up, and this one is incorrect. So our answer for this question is D. So D is the answer what we need to find out. So we need to figure out which option is incorrect. So this is incorrect. Question number 23 says an object is reflected in a plane mirror. Which description of the image is correct? So we are talking about plane mirror. So we need to understand properties of image formed by plane mirror. First property is at the same distance from the mirror. So we can say same distance. Image is formed at same distance as object distance from the mirror. So we can say same distance. And image size, same size as size of the object. Same size. And it is on opposite side of mirror. We can say opposite side. Means opposite to the object. On the other side of the mirror. And image formed is virtual image. You cannot touch that. Virtual image. Now if we have understanding of these points, so we can find out the answer. And same size. So first one is not possible because this is telling you real, and diminished means smaller in size. That's not possible. And large, not possible. Virtual, this is right. Same size, this is fine. Real, this is incorrect. Same size and virtual, this is correct. So the answer for this one is D. Question number 24 says a 100-meter race is started by firing a gun. The gun makes a bang and a puff of smoke at the same time. When does the finishing judge see the smoke, and when does he hear the bang? See the smoke, it is linked with light. And here the bang, this is linked with sound. And the speed of light is much greater than speed of sound. So we can say speed of light is much greater than speed of sound. So this is one thing we need to understand. And speed of light is about equal to 3 times 10 to 8 meters per second. And the speed of sound is about 340 meters per second at room temperature. So we can calculate time. And so for this one, we can find the time. T divided by T will be equal to D divided by V. Distance over time. Distance is 100 meters and the speed of light is 3 times 10 to 8. If we simplify this one, we will get 0.3 times 10 to minus 6. Mean it will take only 0.3 microseconds. So time taken is very short for the light to travel. And for sound, we can also calculate value of T. T is equal to 100 meters divided by the speed of sound. If we solve this one, we will get about 0.3 seconds. So you can see in this case, this is very small as compared with this one. This is 1 million times smaller than this one because this is 10 to minus 6. So for this one, we can say this is just immediately person will see the smoke immediately, but the person will hear the bang after 0.3 seconds, about 0.3 seconds. Now if you have understanding of this one, we can choose the answers. Sees the smoke immediately, this is true. Almost immediately, no. After 0.3 seconds, so first option is incorrect. Almost immediately, yes. After about 0.3 seconds, yes. So the answer for this question is B. So this is how you can figure out. Question number 25 says two magnets X and Y are placed end to end on a bench. The diagram shows the magnetic field pattern between the poles of the magnets. Which row shows direction of the forces exerted on X and Y by the magnetic field? Now for this one, we need to understand magnetic field lines. They start from the north pole. Mean when you have two different magnets, they start from the north pole and they end at south pole. So in this case, simply you can label this one is N, north pole of X, and this is S of Y magnet. So in this case, this pole and this, they are unlike poles. So the force on X will be to the right. So this is the force on X by Y. So we can say this is force on X by Y because this was attractive. Unlike poles, they attract each other. And force on Y by X, force on Y by X, this will be to the left. So if we have this understanding, we can find the answer. If you look at option A, force on axis to the right, this is right. Force on axis to the right, no, it has to be to the left. So this one is wrong. Option B, force on axis to the right, this is correct. Force on y is to the left, so this is also correct. So the answer for this question is B. Question number 26 says the diagram shows a circuit used to control the potential difference across a lamp. The variable resistor is adjusted until the PD across the lamp is equal to 6.0 volts. So this is the PD across the lamp. The current in the lamp is equal to 0.5 amps. So the reading of this one is 6.0 volts and the current passing through this lamp is equal to 0.5 amps. And question is asking us to find out resistance of the lamp. And resistance of the lamp simply is equal to V divided by I. Value of V we have, that is equal to 6.0 volts. Mean this is the PD across the lamp and current is given, that is 0.5 amps. So the answer for this one should be equal to 12.0 ohms. Mean this is the resistance of the lamp. So the answer for this question is D. Question number 27 says a charge Q flows for time t through a resistor of resistance capital R. Which equation gives current I in the resistor? So for this one simply we can sketch. So you can simply imagine that we have resistor and resistance of this resistor is capital R. And charge Q flows through this resistor in time t. And we need to find out what is current. Current is equal to rate of flow of charge. Means the total amount of charge passing through a point in a given time interval. Means delta Q by delta T. In this case, delta Q is given, that is equal to Q. And the time taken is T. So the answer for this question is C. I is equal to Q over T. Question number 28 says a plastic rod is rubbed with a dry woolen cloth. The rod becomes positively charged. Which statement is correct? Rod become positively charged. So simply in this case you can write down, it is given to you that rod become positively charged. If rod become positively charged, it means rod is losing electron. So we can say losing electrons. So rod loses electrons. So rod is losing electrons and the woolen cloth will be gaining electrons. Only electrons move. Positive charges do not move. Gaining electrons. So we will say gaining electrons. So this is the main idea you need to understand. Only electrons move. If one become positively charged, it means that one is losing electrons and the other one will be gaining electrons because total charge remains constant by law of conservation of charge. And so it simply means that electrons move from the rod because this is moving electron. So electron will move from the rod to the cloth. So the answer for this one is A. Question number 29 says which diagram shows a graph of current against voltage for a filament lamp? For a filament lamp, we need to understand as potential difference across filament lamp increases, resistance of filament lamp increases. Means if V across filament lamp increase, PD across filament lamp increase, resistance of filament lamp also increases. Resistance of filament lamp increases because if potential difference across filament lamp increase, it means more electrical energy has been converted into thermal energy. So that's the reason temperature of filament lamp will increase and resistance of filament lamp also will increase. Now we need to understand resistance is equal to delta V, mean the potential difference across the resistor divided by I, current passing through the resistor. So we can also say this one is delta I. If you look at these given curves we can try to find out in which case resistance is increasing. One way to find out is if I draw, let's say, certain lines here. So let's say I draw one line here for the same change in voltage, and I can also draw another line from here, another line here, and we can draw another line here. Now from here you can see it is very clear that for the same change in voltage, increasing current is getting smaller and smaller. So if I draw another one here, so you can see here. So this one we can redraw so it looks proper. So we can also draw another dotted line here. So in this case you can see, first of all, for this delta V, we have in change in I, this is equal to this di, delta I. And for the same increase in delta V, we have smaller increase in delta I. And next you can see for the same increase in delta V, we have the smaller increase in delta I. So you can simply see in this case, as this one, we are just assuming delta V, if we keep constant, delta I is getting smaller and smaller. So it means the resistance is increasing. So this is one way to understand. But the better way to understand this one is we can clear this one, and let me explain you the proper method you will be using at A2 level. For that purpose, simply you can take different points. Let's say I take one point here and I draw the secant line here. Mean this line from that point to the origin. I can choose another point here, so I can draw a secant line here. And the last one, I'll be using red color. So I can take one point here and I can draw the secant line. So this is the secant line. And also in this case, you can see resistance is equal to delta V by delta I. But for this one, you can see the gradient of this one. Gradient is equal to delta I by delta V. So we can say gradient is equal to 1 over R. Gradient is equal to 1 over R. And in this case, you can see the gradient of this secant line is decreasing. If this gradient is decreasing, so it means R has to increase. So in this case, resistance is increasing with voltage. So this is a proper way to find is the resistance is increasing or decreasing. So simply you can draw this secant line and you can find out the gradient. So in this case, gradient of secant line is decreasing. It means that the resistance is increasing. So the answer for this question is D. Question number 30 says each potential divider is placed in a circuit with a power supply. Which potential divider makes the potential difference across component Y increase when the light intensity increases? Light intensity increases, it means there is LDR in the circuit. So if you look at option C, this is the thermistor. So it means there is no, in this case, there is no LDR. So it means this is not possible. And also if you look at option D, there is no any LDR. This is thermistor. So this option is also not possible. So answer is A or answer is B. If we look at option B, and if we connect our voltmeter here, so this is our voltmeter. If we connect voltmeter across this one, as light level will increase, resistance of component Y will decrease. As resistance will decrease, V across this one also will decrease, because resistance of this component is constant and current passing through this resistor will increase. So the potential difference across X will increase and potential difference across Y will decrease. So we can also connect voltmeter here. Let's say this is voltmeter, and the resistance of this one is V across this one is equal to I times R. As current will increase when the total resistance of the circuit will decrease, V across this one will increase, but EMF is constant. So we can say EMF will be equal to Vx plus Vy. As this one will increase and this is constant, so this has to decrease. So in this case, PD across Y will decrease, but we need to find out potential divider where V across Y is increasing. So this one is true. If we connect voltmeter across component X, this V will decrease when light level will increase. So V across this one has to increase. So the answer for this question is A. Question number 32 says which diagram shows the circuit symbol for a fuse? This circuit symbol is for fixed resistor. So this is fixed resistor. And this symbol is for variable resistor. So you need to be able to identify these symbols. So this is variable resistor. And this is representing heater. So this is heater. And this one is representing fuse. So the answer for this question is D. Question number 34 says 4 small compasses are placed around a solenoid. The current is now switched on in the solenoid. Which diagram shows possible new directions of the compass needles? Now, if you look at given options, option A and B, they are not possible because magnetic field at this point, it has to be to the right or it has to be to the left. That it is given to you, magnetic field is pointing vertically downwards. So this is not possible answer. This is also not possible answer. Now, the the answer can be C, our answer can be D. Now if you look at current, in this case this is current. If you look at this end, current here is leaving the solenoid, but if we little go back, so if we look at this point here, current will be up. So current at the front of the solenoid is up. So it means that this side is N. This side will be N. You can use your right hand grip rule. Thumb will point in direction of North Pole. So current at the front of the solenoid is up. So you can see here, current is up at the front. So here. So this is North Pole. Magnetic field lines, they leave the North Pole, but this is telling you they are entering the North Pole. So this option is incorrect. But now if you look at option D, in this case current has the same direction, so current is leaving the solenoid. So current at the front of the solenoid, this is up, so current is up. So again you can use your right hand grip rule. So you can place your fingers here. Current at the front of the solenoid is up, so the left side is the North Pole. So this is the North Pole, and this one is the South Pole. So magnetic field lines leave the North Pole. So we can draw our magnetic field lines. So they will make a loop. So they will form this loop. So this is direction of magnetic field here. So entering, so this is correct, this is correct, this is also correct. Now we can use a different color. So we can draw another loop. Magnetic field lines leave the North Pole and they enter the South Pole. So they will form loop like this. So this one is correct, this is correct because this is direction of magnetic field lines. And this is also correct. So the answer for this one is D. Question number 35 says transformers are used in the transmission of electrical power to houses. Which type of transformer is used at the power station prior to connection to the power lines? And which type is used prior to delivery to the houses? For this purpose, simply we can draw power station. So this is representing power station. And also we can draw electrical pylons for transmission of electrical power. So these are pylons. And here we have a suite home. So simply we can say this is home, suite home. After power station, we have to use step up transformer. So this is step up. So why we have to use step up transformer? Because in this case we can increase the voltage and we can reduce the current. So the energy loss, this is equal to I squared times R. So if we increase voltage, we can reduce current. So in this case, we can reduce energy loss in the cable. So that's the reason we have to use step up transformer. Then we have this cable passing over these pylons. And before the home, we have to use step down transformer. Because the voltage for our home uses, we need very low voltage. So this one has to be step down transformer. Because appliance in the home, they don't need very high voltage, so we have to reduce. So we have to use step down transformer. Power station, step up. Before house, step down. So this one is right answer. So the answer for this one is C. Question number 36 says the diagram shows an AC generator rotating in a clockwise direction. What are the names of parts 1 and 2? Means what is name of this part and what is name of this part. So this one is the brush, carbon brush. So this is carbon brush. And what is name of this ring? And this one is slip ring. So simply the answer for this question is one is brush and the second one is slip ring. In motor, we use split ring. So you have to understand the difference. In motors, we use split ring. In generator, slip ring. Split ring is like this. So you have part of the ring, half ring here and half ring is here. So this is called split ring. But in generator, we use slip ring. Means one complete ring. So this one is slip ring. You need to understand the difference between split ring and slip ring. Split ring is used in motors and in generator we use slip ring. So the answer for this question is A. A is the answer. Question number 37 says a thin metal foil is placed in a vacuum. Alpha particles are fired at the foil and most of the alpha particles went straight through. A very small proportion of the alpha particles are deflected through large angles. What does this provide evidence for? For this one, simply you need to understand these dotted, they are representing atom, mean the size of the atom. So this circle is representing size of the atom. And at the center of the atom, we have nucleus. So this red dot is representing nucleus. And these dotted, they are representing alpha particles. So in this case, you can see most of the alpha particles, they went straight through. Only very few alpha particles, they are deflected through large angles, as you can see this one. So this is deflected through large angle. So what this is telling us about structure of the atom, it simply tells us that size of the nucleus is very small as compared with size of the atom, and most of the atom is empty space. That's the reason these alpha particles, they just went straight through. So simply in this case, answer has to be C, because C is telling us there is a tiny nucleus in each atom. So the answer is C. Question number 38 says thorium-230 is represented by this symbol. This isotope is radioactive and decays to radium by emitting alpha particles. So this is simply alpha decay. We need to find out which nuclide is produced by this decay. So first of all, in this case, we have thorium-230. This one is parent nucleus. So simply we can label this one. And this decays to radium by emitting alpha particles. So here we have alpha particle. So we have 90 protons here, 2 here, so this one has to be 88, means the atomic number. And mass number is 230, we have 4 here, so 230 minus 4, this has to be equal to 226. So the answer for this question is A. Question number 39 says the diagram shows a piece of apparatus used to determine the nature of the emissions from a radioactive source. The absorbers can be raised out of or lowered into the path of the radiation from the source to the detector. The apparatus is evacuated. The table gives a set of results for a particular radioactive source. We need to find out which types of radiation are being emitted by the radioactive source. So in this case, first of all, it is given to us absorber in use. Nothing is between absorber and the source, and the total amount of radiations, means the count rate, is equal to 350. And then we place a thin paper. Thin paper can stop alpha particles. So simply we can say alpha particles can be stopped by thin paper. But there is no change in count rate. It means no alpha particles. So simply we can say no alpha particle. And then we place aluminium, sheet of aluminium, that is 1.0 mm, and count rate decreases. So it simply means that beta particles are present, because aluminium can stop beta particles. So beta particles are present. So here we can say no alpha particles. And then we place lead, and again count rate decreases. So it means gamma radiations are also present. So we have beta and gamma present. So the answer for this question is C. So this is how you can figure out. Question number 40 says the graph shows the measured count rate of radiation from a source containing a radioactive isotope. The detector is in a laboratory with no shielding from background radiations. It simply means that we cannot ignore background radiations. We have to consider background radiations in our calculations. So we can simply write down background radiations. So in this case, background radiations are not negligible. For this question, we need to find out what is the measured count rate after a time of 1 half-life. After 1 half-life, measured count rate simply will be equal to, you can say, measured count rate. Measured count rate simply will be equal to initial value, initial count rate, plus count rate due to background radiations only. And Y is representing count rate due to background radiations only. So you have to add these two and you need to divide by 2. So the answer for this question has to be D. Let's try to determine half-life for this given graph. If you look at this graph, you can see after this period of time, count rate is constant, and this count rate is due to background radiations only. only. So it means in this case background radiations are not negligible, means we cannot ignore. So how we can calculate half-life? For this one, simply you have to follow this formula. We have discussed that measured count rate, this is equal to initial count rate plus count rate due to background radiations divided by 2. So in this case, initial count rate is 170. And due to background radiations, count rate is equal to 10. So simply we can add 10 divided by 2. So this one will be equal to 90. So this is measured count rate after one half-life. So now simply we can find out count rate when it is equal to 90. So the count rate is at this point, you can see this is 80. So this will be 84, this will be 88. So halfway, this one is 90. So we can draw the line. So we can draw this dotted line. So this count rate is 90. So simply halfway here. So this is 90. Not very good. So let me redraw this one. So we can redraw. So half count rate is equal to 90. So this is equal to 90. And we can also draw one line on time axis. So this is on time axis. So you can simply read half-life from here. So this is 2, this is 1. So this is 1.2, this is 1.4, this one is 1.6. So the half-life in this case is equal to 1.6 hours. So this is how you can calculate measured count rate, and then you can find the half-life. I hope this video was helpful. If this video helped you to improve your conceptual understanding and also give you better understanding of this paper, then please like and subscribe the channel, because your encouragement is very important. And also you can find a lot of videos about AS physics, about A2 physics with step-by-step solution. And also you can find videos on this channel about physics competitions like Physics Bowl, BPHO, and also about university admission tests such as PAT for Oxford University and ENGA for Cambridge University. And a lot of more videos are coming about physics competitions and also AP physics in future. I hope you will find these videos very helpful and you will improve your understanding of physics so you can explore more about the universe. That's all for today's video. I'll see you in next video.